Welcome back to Samathics. We are going to solve Additional Mathematics, Paper 1, Non-Calculator, 4037, Variant 1-2, May-June 2025. Question number 1. The diagram shows the graph of y is equal to absolute of x, where f is a cubic polynomial. Find expressions for the two possible functions f of x. Write each expression in fully factorized form. First of all, we will find out what are the x-intercepts. If we see, this is minus 2 over here. Here it is minus 0.5. And here is 3. And all these are x-intercepts. So x is equal to minus 2. X is equal to minus 0.5. X is equal to 3. This 2 is y-intercept. So we can write here y is equal to 2. Here x is equal to 0, and on x-axis y is equal to 0. Let's form an equation. With these values of x, we will find out factors. First of all, we will change it into fraction. X is equal to minus 1 upon 2. These values will remain same. X is equal to 3 and x is equal to minus 2. Now we can write this here as x plus 2. One of the factor is x plus 2. Another factor is we will multiply 2 by x and we will take minus 1 on this side. So it will become 2x plus 1. Third factor is x minus 3. Now we have to find an expression for f of x. F of x is equal to x plus 2, 2x plus 1, x minus 3. When we will multiply 2 by 1 by minus 3, we are getting minus 6. But the y-intercept is 2, so it means that we have to multiply it by minus 1 upon 3 so that we get the y-intercept as positive 2. Now, for this y-intercept, the sign is to be negative and the original curve is to be like this, starting from here and then from here and then this, and then this has to be like this. So this is the curve whose equation is minus 1 upon 3 x plus 2, 2x plus 1, x minus 3. Another possibility is that the graph is starting here. It is like this. So for this graph, expression for f of x is plus 1 upon 3 x plus 2, 2x plus 1 into x minus 3. So these are the two expressions which were required, which they have asked in the question. Question number 2, solve the equation x power 1 upon 3 plus 1 is equal to 6 upon x power 1 upon 3. This is a hidden quadratic equation. We have to consider x power 1 upon 3 as y. So when we will consider x power 3 as y, then the equation will become y plus 1 is equal to 6 upon y. When we will do cross multiplication, we will get y squared plus y is equal to 6. Then we have y square plus y minus 6 is equal to 0. So y square plus 3y minus 2y minus 6 is equal to 0. We are doing middle term breaking. Y is common, y plus 3. Then minus 2 is common, y plus 3 is equal to 0. One of the factor is y minus 2. Another factor is y plus 3. We'll take out the values of y. Y minus 2 is equal to 0 and y plus 3 is equal to 0. Y is equal to 2 and y is equal to minus 3. We replaced x power 1 upon 3 by y. Now we will replace y by x power 1 upon 3. So x power 1 upon 3 is equal to 2 and x power 1 upon 3 is equal to minus 3. We can take cube on both sides so that we can take out the value of x. So here this and this would be cancelled out. So x is equal to 8 and here x is equal to minus 27. Question number 3. A circle with center C has the equation x squared plus y squared minus 10x minus 4y plus 24 is equal to 0. Show that the line y is equal to 2x minus 3 is a tangent to the circle. First of all, we will change this equation to x minus a whole square plus y minus b whole square is equal to r square. So that we can solve these two equations simultaneously and find out the intersection point. And then with the help of that intersection point, we can take out radius, and if the radius is same as this radius, then we can say that the line y is equal to 2x minus 3 is a tangent to the circle. So to change this equation to this form, we have x squared minus 10x. So it will become x minus 5 whole square, then square of 5. Then we have here y squared minus 4y. So it will be changed to y minus 2 whole square minus 2 square is equal to 24. So we have now x minus 5 whole square plus y minus 2 whole square is equal to 24 minus 5 square is minus 25 minus 2 square is minus 4. So minus 25 and minus 4 will become minus 29, which we can write over here as plus 29. This is to be minus 20. So we have here x minus 5 whole square plus y minus 2 whole square is equal to 5. This is another form of the equation of circle. Now, with the help of this, we can find out what is radius and what is center of the circle. So 5, 2 is the center of the circle and r square is equal to 5. So r is equal to under root 5. We have taken out the coordinates of the center of the circle and radius. Now we will solve these two equations simultaneously so that we can find out the coordinates of intersection point of circle with the tangent. So if we will substitute y is equal to 2x minus 3 in this equation, we will get x squared plus 2x minus 3 whole square minus 10x minus 4 into 2x minus 3 plus 24 is equal to 0. So we have here x squared plus 4x squared. 2x into 3 is 6x multiplied by 2 minus 12x plus 9 minus 10x minus 8x plus 12 plus 24 is equal to 0. Now we have here 5x squared minus 30x plus 45 is equal to 0. We can take 5 as common. X squared minus 6x plus 9 is equal to 0. We can write this as x minus 3 is equal to 0. You can use middle term breaking, or you can use identity that x squared minus 6x plus 9 is equal to x minus 3 whole square. So the value of x here is 3. For y, we will substitute this 3 into equation y is equal to 2x minus 3. So 2 3s is 6 and 6 minus 3 is 3. So y is equal to 3. So we have got the coordinates of intersection point of circle with tangent. Now we will use the coordinates of center of the circle and the intersection point of the circle with the tangent, which is 3, 3, to find out radius. So if we will find out radius, the radius is the distance between the intersection point and the center of the circle. So we will take out radius, which is 3 minus 5 whole square, 3 minus 2 whole square. So we have here 3 minus 5 is minus 2 whole square is 4. So it is 4. 3 minus 2 is 1. 1 square is 1. So the radius here is under root 5. And by converting this equation into this form, we have got the radius as under root 5. So it is shown that the line y is equal to 2x minus 3 is tangent to circle, whose equation is x squared plus y squared minus 10x minus 4y plus 24 is equal to 0. Given that this tangent touches the circle at the point P, find the coordinates of P. We have already taken out the point of intersection of the circle with the tangent. So we can just write down the coordinates here. The coordinates of P are 3, 3. Now, part C. Find the equation of the circle which has its center at P and passes through the origin. 0, 0 are the coordinates of origin. 3, 3 are the coordinates of the center of the circle. We will take out radius using these two coordinates. 3 square plus 3 square, which is 9 plus 9 is equal to under root 18. So now we can form the equation of the circle which is passing through the origin, and P is a center. So x minus 3 whole square plus y minus 3 whole square is equal to 18. R square. So here R is under root 18. So its square is 18. So this is the equation of the circle. Let's move on to the next question. Question number 4. Part A is find integral of sine theta d theta with limits pi to 0. First of all, we will integrate it. When we will integrate sine theta, we will get minus cos theta. And the limits are from pi to 0. So one time we will substitute theta as pi minus cos pi. Another time we will substitute theta as 0. You must know that cos pi is cos 180 degree, and at 180 degree the value of cos is minus 1. So we can write here minus into minus 1. Then minus cos 0 is 1. So this will be minus 1. Minus multiplied by minus, it will be plus 1. Minus multiplied by minus will be plus 1. So 1 plus 1 is equal to 2. You must know the values of cos at pi, 0, 2 pi, and pi upon 2. Part B, given that alpha is greater than 0 and less than pi upon 2, show that sec alpha upon cot alpha plus tan alpha can be written as sin alpha. First of all, we can write it as sec alpha divided by cot alpha plus tan alpha. Then sec alpha can be written as 1 upon cos alpha divided by cot alpha is cos alpha divided by sin alpha plus tan alpha can be written as sin alpha divided by cos alpha. This will remain 1 upon cos alpha. We can take here LCM. When we will take LCM, it is sin alpha into cos alpha. So this cos alpha is to be multiplied by cos alpha. So this would be cos square alpha plus sin square alpha. In the denominator of cos alpha is sin alpha, so we'll multiply it by cos alpha. In the denominator here, it is cos alpha, so this is to be multiplied by sin alpha. Now, we can take cos square alpha plus sin square alpha as 1. So 1 upon cos alpha divided by 1 upon sin alpha into cos alpha. Now we can change this division into multiplication. So this will become 1 upon cos alpha multiplied by sin alpha cos alpha. Now this cos alpha and cos alpha will be cancelled out. So we will be left with sin alpha. So we have proved that sec alpha divided by cot alpha plus tan alpha can be written as sin alpha. Question number 5. The polynomial p is such that p of x is equal to 3x cubed minus 7x squared plus ax plus b, where a and b are integers. It is given that p prime minus 1 is equal to 21, and that x minus 2 is a factor of px. Find the values of a and b. Whenever we have to find out the values of two variables, then we have to form two equations. For those two equations, they have given two conditions. One of the condition is that when you differentiate this px and substitute minus 1 into that, that is equal to 21. And another condition is that x minus 2 is a factor of px. So you will take out the value of x from here and substitute it in that, which will be equal to 0, because the remainder is 0 if x minus 2 is a factor. So first of all, we will find out expression for differential of p of x. So when you will differentiate this, you will get 9x squared minus 14x plus a. Now when you will substitute minus 1 into this, then it will be equal to 21. So here we can substitute 21. 21 is equal to minus 9 plus 14 plus a. Here it is square, so it is to be plus 9. So 21 minus 23 is equal to a. So a is equal to minus 2. So we have got the value of a from the first condition. Now we will apply the second condition. According to that, if we will substitute 2 into the expression p of x, it will be equal to 0 because x minus 2 is a factor. We'll substitute the value of a as well. Plus b is equal to 0. So 2 cube is 8, 8 threes are 24. 2 square is 4, 4 sevens are 28, minus 28 minus 4 plus b is equal to 0. 24 minus 24 is 20, and 20 minus 28 is minus 8. So minus 8 plus b is equal to 0, and b is equal to 8. Part B, hence write p of x as a product of linear factors with integer coefficients. So the p of x is 3x cubed minus 7x squared minus 2x plus 8, which is equal to x minus 2, which is the factor of p of x, into ax squared plus bx plus c, the quadratic factor. So we will take out the values of a, b, and c, and then we will factorize to find out the linear factors. So first of all, we will expand. We will multiply x by ax squared. So this is ax cubed. Minus 2 into ax squared is minus 2ax squared. X into bx is plus bx squared. Minus 2 into bx is minus 2bx. And x into c is plus cx. And minus 2 into c is minus 2c. Now we will equate the coefficients of x cubed. Here, the coefficient of x cubed is a, and here the coefficient of x cubed is 3. So a is equal to 3. Then we can equate constant terms. Here we have 8, and here we have minus 2. So 8 is equal to minus 2. So c is equal to minus 4. 8 divided by minus 2 is minus 4. Then To find out the value of b, we can equate either the coefficients of x or the coefficients of x squared. Coefficient of x squared here is -7. And on this side, the coefficient of x squared is -2a plus b. So we can write -7 is equal to -2a plus b. When we will substitute the value of a as 3 here, this will be -6 plus b. So b is equal to -7 plus 6, which is -1. Now we can substitute these values in this quadratic expression, which is ax squared plus bx plus c. So when we will substitute in this, we will get 3x squared minus x minus 4. We can do middle term breaking. So we have here 3x squared plus 3x minus 4x minus 4. We can take 3x as common, x plus 1, minus 4 as common, x plus 1. So we have 3x minus 4, x plus 1. So Px can be written as a product of linear factors as x minus 2, 3x minus 4, and x plus 1. Part C, using your values of a and b, solve the equation 3e power 6y minus 7e power 4y plus a into e power 2y plus b is equal to 0. If you compare this expression with the expression which was given in the question as p of x, like 3x cubed minus 7x squared minus 2x plus 8, it is the same. So we have here 3e 2y and then power 3 outside minus 7e power 2y square. We'll substitute the value of a, which was -2. So minus 2e power 2y plus 8 is equal to 0. If we compare this expression with this, it is the same, 3x cubed minus 7x squared minus 2x plus 8. In place of x, we have e power 2y. So it means that the factors of this will be the same as we have taken out in the previous part. So here we can write the first factor is x minus 2. So we can write here 2e power y minus 2. Then 3e power 2y minus 4 and e power 2y plus 1 is equal to 0. Now we can find out the values of y by equating e power 2y minus 2 to 0, then 3e power 2y minus 4 is equal to 0, and e power 2y plus 1 is equal to 0. So we have here e power 2y is equal to 2. So this will become 2y ln e is equal to ln 2. Ln e is equal to 1. So y is equal to ln 2 divided by 2. We can write it as y is equal to 1 upon 2 ln 2. 3 e power 2y is equal to 4. We can write 2 e power y is equal to 4 upon 3. We can apply ln on both sides. So 2y ln e is equal to ln 4 upon 3. Ln e is 1, so y is equal to 1 upon 2 ln 4 upon 3. In this case, e power 2y is equal to minus 1. If we'll apply ln here, 2y ln e is equal to ln minus 1, which is not possible. Because we cannot apply ln on negative number. Question number 6. When ln y is plotted against x cube, a straight line passing through the points 2, 5 and minus 8, 25 is obtained. If we draw a rough sketch of this. Then the graph would be somewhat like this. We have 2 points here, 2, 5, minus 8, 25. We have to find the equation of this line. ln y, we have ln y. In place of x, it is x cubed. We have to find y in terms of x. It means that we will find out the equation of this line and then we will make y the subject. So first of all, we will find out gradient, which is m and which is y2 minus y1 upon x2 minus x1. So 25 minus 5 divided by minus 8 minus 2, which is equal to 20 upon minus 10, and finally, which is equal to minus 2. For C, we will substitute m and one of the coordinate into y is equal to mx plus c. So 5 is equal to m, which is minus 2, into x, which is 2 plus c. 5 plus 4 is equal to c. So c is equal to 9. Now we can substitute these values into the equation y is equal to mx plus c. In place of y, there is ln y. In place of m, there is minus 2. In place of x, it is x cubed. And in place of c, it is 9. Y is equal to e power minus 2x cubed plus 9. We have changed this log form to index form. The base of ln is e. So this whole will become the power of e when we will be changing into index form. Part B, find the value of x when y is equal to e power 25. So we will substitute e power 25 in the equation we have got in the previous part. On both sides, e is a base, so we can cancel out bases and we can equate the powers. If the bases are same, powers are equal. Now we can solve it. 25 minus 9 is 16 is equal to minus 2x cubed, and x cubed is equal to minus 8. And when we will take cube root on both sides, then we will get x is equal to 2. So x is equal to minus 2. Cube root of minus 8 is minus 2. Question number 7. A geometric progression has a fourth term of 8k power 6 divided by 27 and a sixth term of 32 k power 10 upon 243, where k is a constant. The common ratio of this geometric progression is positive. Find the common ratio in terms of k and the value of first term of this geometric progression. First of all, we will see fourth term of a geometric progression is 8k with power 6 upon 27. So, in geometric progression, fourth term is a into r cube, which is equal to 8k power 6 divided by 27. And sixth term is 32k power 10 upon 243. So sixth term of the geometric progression is ar power 5, which is equal to 32k with power 10 upon 43. 243. We can make a the subject from both of these equations. So a is equal to 8k power 6 divided by 27 into r cube. This r cube will go to denominator. And here a is equal to 32k power 10 divided by 243 into r power 5. We can equate both the values of a. So 8k power 6 divided by 27 r cube is equal to 32 k power 10 divided by 243 r power 5. As we have to take out the common ratio, so we will take r on this side, so we can write r power 5 over here. R cube will remain at its place. 32 k power 10 is to be multiplied by 27 and divided by 8 will be multiplied by 243 and k6. We will take this 8 k6 this side on the denominator. So r power 5 and r power 3 when will be solved is equal to r square is equal to, we can cancel out this, 8 ones are 8 and 8 fours are 32. Then 3 8s are 24, 3 ones are 3, 3 9s are 27, and 9 ones are 9, and 9 9s are 81. So we have here 4 upon 9, k power 10 minus 6 will be k power 4. We can take square root on both sides, so this will be r. Square root of 4 is 2, square root of 9 is 3, and square root of k power 4 is k square. As the common ratio is positive, so we will just consider the positive value. We will not consider here negative value. And then we have to find out the value of the first term. It means that we have to take out a. For a, we will substitute the value of r into either in this equation or in this equation. So we will use this equation, 8k power 6. Instead of writing in the form of fraction, we can put here divide, and then we can write 27 r cube. In place of r, we can write here 2 upon 3 k square with power 3. We have substituted the value of r here. So we have here 8k6 divided by 27 into 2 cube is 8, 3 cube is 27, k square with power 3 is k power 6. This and this would be cancelled out. So 8k power 6 divided by 8k power 6 is equal to 1. So the value of r is 2 upon 3k squared and the value of a is 1. Given that this geometric progression has a sum to infinity of 3, find the possible values of k. So sum to infinity is equal to a upon 1 minus r. Sum to infinity is given as 3. The value of a is 1 divided by 1 minus 2k squared upon 3. 3 is equal to 1 upon 3 minus 2k squared upon 3. We can do cross multiplication. 3 multiplied by 3 minus 2k squared upon 3 is equal to 1. So this 3 and this 3 would be cancelled out. We will take minus 2k squared on this side and 1 on this side. So it will be 3 minus 1 is equal to 2k squared. So 2 divided by 2 is equal to k squared. And k is equal to plus minus 1. Because k squared is equal to 1, and then we will take square root on both sides, then k is equal to plus minus 1. Question number 8. It is given that y is equal to ln 3x squared plus 16 upon x plus 2. Find dy upon dx when x is equal to 0. Give your answer in the form ln p, where p is a constant. As we know, here ln 3x squared plus 16 is divided by x plus 2. We will consider this as u, this as v. So u is equal to ln 3x squared plus 16, and differential of u is 3x squared plus 16, and here we will have 6x. v is equal to x plus 2, and differential of v is 1. So dy upon dx is equal to v into differential of u. So x plus 2 into 6x divided by 3x squared plus 16 minus u into differential of v ln 3x squared plus 16 into 1 divided by v squared, which is x plus 2 whole square. As we have to find out dy upon dx when x is equal to 0, we don't need to simplify it. We can just substitute the value of x as 0. So if we will substitute here 0, then this will become 2. And when we will substitute here 0, then 6 multiplied by 0 would be 0. So this whole fraction will become 0. Then minus ln, when we will substitute here 0, then 0 multiplied by 3 is 0. So we will be left with ln 16 divided by, we will substitute here 0. 0 plus 2 is 2 and 2 square is 4. So we have here minus ln. We can write 16 as 2 power 4. Divided by 4 is equal to minus 4 divided by 4 ln 2. So this and this would be cancelled out. So we are left with minus ln 2. If we'll make this negative sign the power of 2, so this will become ln 2 power minus 1. It is ln 1 upon 2. So dy upon dx is ln 1 upon 2 when x is equal to 0. Given that x increases from 0 to h, where h is small, write down the approximate change in y. Delta x here is equal to h minus 0, which is h. Delta y is to be taken out. Write down the approximate change in y. So we will use delta y upon delta x is equal to dy upon dx. So delta y is to be taken out. Delta x is h. And dy upon dx we have taken out in the previous part, which is ln 1 upon 2. So delta y is equal to h ln 1 upon 2. Question number 9. It is given that f of x is equal to 2 ln 3x minus 4 for x is greater than a and that f inverse exists. Find the least possible value of a. For ln function, 3x minus 4 must be greater than 0. This cannot be negative. This will always be positive. So we can write here 3x minus 4. Then when we will simplify it, we will get 3x is greater than 4. So x is greater than 4 upon 3. The least value of a is 4 upon 3. For your value of a, write down the range of a. As we know, this is ln function. So when we will sketch the graph of this, we will be getting the graph like this. So we can see that the value of y goes to infinity here, and here as well it will go to infinity. So y belongs to real number. For your value of a, find an expression for f inverse of x. Y is equal to 2 ln 3x minus 4. We have to make this x the subject. So first of all, we will take 2 to the denominator. Y upon 2 is equal to ln 3x minus 4. This can be written as the base of ln is e, so e power y upon 2 is equal to 3x minus 4. So x, we have to make x the subject, which will be x is equal to e power y upon 2 minus 4. When we'll go on that side, it will be plus 4. And this will be divided by 3. So we can write f inverse of x is equal to e power x upon 2 plus 4 divided by 3. Part D, it is given that the equation of f of x is equal to f inverse of x has two roots. It means that the graph of f of x and f inverse of x are intersecting at two different points. For your value of a, sketch the graphs of y is equal to f of x and y is equal to f inverse of x on the axis. Label each graph, state the intercepts of each graph with the axes, and state the equations of any asymptotes. As we know, the graph of ln function would be in first and fourth quadrant. First of all, we will take out where the graph intersects the x-axis. For that, we have to take y as 0. So we have equation y is equal to 2 ln 3x minus 4. So we will take y as 0. So when we will take y as 0, 0 is equal to ln 3x minus 4. 2 will be divided by 0, so it will be 0. We can write it in index form. E power 0 is equal to 3x minus 4. So 1 plus 4 is equal to 3x, and x is equal to 5 upon 3, or we can say that x is equal to 1 whole 2 upon 3. So we have coordinates 1 whole 2 upon 3 comma 0. So it means for f inverse of x, the coordinates are 0 comma 1 whole 2 upon 3. Now we will draw the graphs. As we know, whenever we draw the graph of function and its inverse, then we have to draw the line of y is equal to x. So first of all, we will draw a line of y is equal to x. First of all, we will draw a line of y is equal to x. X-intercept here, 1 whole 2 upon 3. If we consider 1 whole 2 upon 3 here, then here is an asymptote, right? The graph of f of x would be like this. Graph of f inverse of x would be like this. Here is the asymptote, and here is another asymptote. This is the graph of y is equal to f of x. as they have said to label each graph. So this is the graph of y is equal to f of x. This is the graph of y is equal to f inverse of x. This is 5 upon 3 comma 0. This is 0 comma 5 upon 3. For your understanding, I have attached the graph drawn through graphing calculator. So you can see the graph is to be like this. This is the graph of f inverse of x. And this is the graph of f of x. These two graphs are intersecting at these 2 points. Question number 10. The diagram shows the shape OA, B, C, D, E, F. AOF is a straight line. OAB and OEF are sectors of a circle with center O and radius R. Angle BOA and angle EOF are equal. These two angles are equal. OCD is a sector of a circle with center O. OCD is a sector of a circle with center O and radius 4r upon 3. Angle COD is theta radians. The point B lies on the line OC and the point E lies on the line OD. The line BE is parallel to the line AOF. Find in terms of r and theta the area of the shaded region BCDE. If we see this shaded region, this is the area when we subtract the area of this triangle from the area of this sector. So if we have to find out area of shaded region, then this is equal to area of sector minus area of triangle. For area of sector, we have formula 1 upon 2 r square theta. And for area of triangle, we have 1 upon 2 AB sine C. Now we will see we have all the measurements or not. For area of sector, we have radius, which is 4r upon 3. We have theta, which is simply theta. Now we can substitute the values 1 upon 2. R here in this case is 4r upon 3 whole square into theta. Here we have theta. Radius is this one for the sector minus 1 upon 2 AB sine C. If we see this triangle, this is the radius, right, of this sector. So we can consider this as R and this as well as R. So we can write here 1 upon 2 into R and sine theta. This angle is theta. So when we will simplify it, we will get 1 upon 2, 16 r square upon 9 theta minus 1 upon 2 r square sine theta. So this 2 will be cancelled out. So we can write it as 8 upon 9 r square theta minus 1 upon 2 r square sine. Part B, the diagram shows the shape from part A with region OA, BEF shaded. Find in terms of r and theta the perimeter of the shaded region. For perimeter of the shaded region, we have to add up this arc length, this length, this arc length, and this length. We already have this length r plus r. We can find out this using arc length formula, which is r theta, and this as well r theta. For this, we can apply cosine rule, where we have c square is equal to a square plus b square minus 2ab cos c. So we will have here c is equal to a square plus b square. These are the two sides which are radius. So r square plus r square minus 2 into r into r. Cos c means cos theta. So we have c is equal to r square minus 2r square cos theta, which will be simplified to two r square is to be taken as common, 1 minus cos theta. So this is the length of this side. 2r square, 1 minus cos theta. Now we have to find out the length of these arcs. For this, we require theta. So this is pi minus theta divided by 2. This is also pi minus theta divided by 2, because we will subtract this theta from pi and we will divide it into two parts, as these both sectors are of same size. They have same radius and these angles will also be same. Now we can take out perimeter. Perimeter is equal to this r plus r, which is 2r, plus r theta. R theta is r into pi minus theta upon 2. And the same would be the perimeter of this arc. So we will multiply this by 2. So this 2 and this 2 will be cancelled out, plus square root of 2r square into 1 minus cos theta. So when we will simplify it, it will become 2r plus r into pi minus theta plus under root 2r square 1 minus cos theta. Question number 11. The diagram shows the triangle OAB where OA is equal to A and OB is equal to B. So this from here till here is OA, which is A, and OB, which is B. So this is B. OP is from here till here, which is 3/4 of OA. It means it is 3/4 of A. Then we have AQ, which is AQ is from here till here, which is 1/3 AB. We don't know AB, so we will take out AB. AB is 1/3. AQ is equal to 1/3 AB, and AB is AO plus OB. Which is equal to minus A plus B. AO is opposite of OA, so its direction is changed. So we have to consider here minus A, and OB is the same which was given in the question, so we have taken it as positive. So AQ is equal to 1/3 of AB, so this is 1/3 minus A plus B. OP is 3/4 of A. We have to find OR in terms of A, B, and U. OR is equal to, OR is this, it is equal to OP plus PR. OP is already given, which is 3/4A, and PR is mu times PQ. For PQ, we can take out PQ by PA plus AQ. So we can write mu PA plus AQ. If OP is 3/4 of A, then PA is 1/4 of A. So this is 1/4 of A plus 1/3 of minus A plus B. AQ is 1/3 of minus A plus B, which is simplified to 3/4A plus mu into 1/4A minus 1/3A plus 1/3B, which is finally 3/4A plus mu into, we will take out LCM, where we will multiply this by 4 and this by 3. So 12 will be there in the denominator. 3 minus 4 would be minus 1. So minus 1 upon 12a plus 1 upon 3b. So this is OR, which is in terms of A, B, and mu. Part B, hence find the values of lambda and mu. In the question, OR is given as lambda b, and we have taken out OR in terms of mu, which is 3 upon 4a plus mu minus 1 upon 12a plus 1 upon 3b. As both are the values of OR, so we can equate lambda b is equal to 3 upon 4a plus mu into minus 1 upon 12a plus 1 upon 3b. So lambda b is equal to 3 upon 4a minus 1 upon 12 mu a. We will multiply mu by a, mu by b. So this will be 1 upon 3 mu b. We will take 3 upon 4 minus 1 upon 12 mu as common, and we will write here a plus 1 upon 3 mu into b. We can see here there is no term in a, so we can write that as 0a. A with coefficient 0. Now, we can equate the coefficient of a here 0 and the coefficient of a here, which is 3 upon 4 minus 1 upon 12 mu. And we can equate this lambda to minus 1 upon 3 mu to find out the values of lambda and mu. So 0 is equal to 3 upon 4 minus 1 upon 12 mu. 1 upon 12 mu is equal to 3 upon 4. We'll take this on this side. Mu is equal to 36 upon 4. So mu is equal to 9. Then lambda is equal to 1 upon 3 mu. So lambda is equal to 1 upon 3 into 9. So lambda is equal to 3. So we have got the values of lambda and mu. Lambda is equal to 3 and mu is equal to 9. Now the last question, question number 12. A curve is such that its gradient at the point xy is given by 5x minus 2 with power 1 upon 3. The curve passes through the point 2, 32.5. Find the coordinates of the stationary point on the curve. As we have to find out the coordinates of stationary point of the curve, we require both the values of x as well as y. So to take out the value of x, we will simply equate this dy upon dx to 0. But to find out the value of y, we must have an equation of curve, for which we have to integrate this and find out the equation so that we can easily take out the value of y. So first of all, we will take out the equation. We have dy upon dx is equal to 5x minus 2 with power 1 upon 3. So if we have to take out the equation, then y is equal to integral of 5x minus 2 with power 1 upon 3 dx. So y is equal to 5x minus 2 with power 4 upon 3. 1 upon 3 plus 1 will be 4 upon 3 divided by 4 upon 3 by 5 plus c. So when we will simplify this, it will become 20 upon 3. We will take 3 to the numerator. So the equation of y is 3 into 5x minus 2 with power 4 upon 3 divided by 20. Now to take out the value of c, we have here x 2 and y 32 upon 5. So we will substitute 32 upon 5 is equal to 3 into, when we will substitute here 2, 2 5s are 10, 10 minus 2 is 8, it will be 8 power 4 upon 3 plus c. So this is 32 upon 5. As it is 3 here, so cube root of 8 is 2 and 2 power 4 is 16. And 16 multiplied by 3 is 48. So 48 upon 20 plus c, we can simplify it. 4 5s are 20 and 4 12s are 48. So we will have 32 upon 5 minus 12 upon 5, which is equal to c. So c is equal to 20 upon 5, which is 4. So c is equal to 4. We have got the equation of y as 3 upon 20 into 5x minus 2 with power 4 upon 3 plus 4. Now we will take out the coordinate of x at stationary point, for which we have to equate dy upon dx to 0 for taking out the value of x at stationary point. So 0 is equal to 5x minus 2 with power 1 upon 3. So 5x minus 2 is equal to 0 and x is equal to 2 upon 5. Now we will substitute this into equation. Y is equal to 3 upon 20 into 5 into 2 upon 5 minus 2 with power 3 upon 3 plus 4. So y is equal to 3 upon 20. When we will cancel out 5 and 5, 2 minus 2 will be 0. So this whole will become 0 plus 4. So y is equal to 4. The coordinates of the stationary point on the curve are 2 upon 5, 4. I hope you have understood the concept of all the questions which we have discussed in this video. Thanks for watching.